Welcome to the deep dive, where today we're drilling down into something pretty specific, high-speed networking standards. And we're going to do it by looking at the product specs for just one cable.
Right. It's the Kramer CLS-2LC OM3, a 164-foot fiber optic cable.
And it might seem simple, but the spec sheet is our blueprint. It's full of these little nuggets about performance, safety, even international data standards.
It really is a deep dive into pure precision. You've got this dual LC multimode OM3 cable, and the core identity is right there in the specs.
Yeah, let's start there. It says MM50125 millimeter wavelength. So that ratio, 50 to 125 micrometers. What is that actually telling us?
Well, that ratio is everything. It defines the fiber. M just means multimode, so light is taking multiple paths down the glass.
Okay.
But the 525 millimeter, that's the diameter of the core and the cladding. So you have a tiny 15 micrometer core carrying the light signal wrapped in a 125 micrometer cladding that keeps the light contained.
And the OM3 part is important, right?
Oh, absolutely. That OM3 designation means it's laser optimized fiber.
So this isn't just for plugging in, some basic extender. The source material says this is ideal for 10 gigabit Ethernet. That's serious speed.
That's very serious speed. Think of it like a performance part for a race car. You wouldn't just use any old piece of metal. The physical details here matter.
Like the dual LC connectors for high-density setups.
Exactly. And even the internal subcables being color-coded blue and orange. It's all about precision, even during installation.
Okay, but the spec sheet then lists this huge string of compliance codes. You've got ITUT, TAE, IEC. I mean, why so much regulation? Isn't a cable just a cable?
But that's the key. It's not just a cable. Those standards guarantee that every single 50125 millimeter cable, no matter who makes it or where, will perform identically under those 10 gigabit conditions.
So it's about interoperability on a global scale.
Precisely. In fiber, precision isn't a feature. It's the absolute foundation of our global networks.
And the consistency must apply to safety, too. The jacket is specifically low smoke and halogen-free, and it's that standard aqua color. What's the deal with that?
That's a huge deal for installations, especially in data centers or big office buildings. Fire safety is non-negotiable.
Right.
That material means if there were a fire, the cable wouldn't release a lot of dense, toxic smoke. It protects people, and it protects the other expensive electronics from corrosive gases.
Okay, that makes a lot of sense.
Yeah.
So let's shift from safety to performance. Insertion loss, or IL. This is basically the signal getting weaker over distance. Yeah.
Exactly. It's measured in decibels, and the spec sheet gives us a perfect example of just how tight the engineering is.
It really does. It says at 10 meters, so about 33 feet, the insertion loss is less than 0.3 dB, which sounds incredibly low.
It is incredibly low, but why does that tiny number really matter when you start stretching the cable out to its limits?
Because even when you go all the way out to 200 meters, that's over 650 feet, the loss is still restricted to less than 1.5 decibels.
And that right there, that minimal decay, is proof of the quality. It's what allows the cable to maintain that high speed and signal integrity over a real distance. It all comes back to that micron-level engineering.
So the big takeaways are all about consistency. The OM3 multimode fiber, that 50125 millimeter measurement, and the 850 nanometer wavelength. That's the formula.
That's the formula for 10 gigabit Ethernet, yeah. And it's all guaranteed by those global standards we talked about.
So after this deep dive, what's the final thought you want to leave with our listeners about all this?
I'd say, consider for a moment why this all exists. Why do we need international bodies managing specifications down to the micrometer just for a passive component, a simple cable?
Because it's not so simple.
It's because that immense hidden complexity is the very engine that drives our modern, reliable, and totally interoperable global network. It has to be that perfect or nothing works.
The deep dive successfully completed. Thanks for supplying the specs for our journey today.